Hello students, this is Punit Kumar, lecturer in mathematics at Sciences PU College. Welcome you all. And we have a question here. A point D on the side BC of an equilateral triangle ABC such that DC is equal to 1/4 times of BC, then prove that AD square is equal to 13 times of CD square. A very simple problem in trigonometry. So let us discuss now how to show that AD square is equal to 13 times of CD square when we have the condition DC is equal to 1/4 into BC. So for that, consider a right equilateral triangle ABC. So suppose this will be an equilateral triangle ABC. So what is meant by equilateral triangle? So when all the sides are equal in length and also the internal angles are same, then the triangle is said to be an equilateral triangle. So let us consider this as an equilateral triangle ABC. Let ABC be an equilateral triangle. Equilateral triangle. Now, what is the given condition, dear students? So given DC is equal to 1/4 into BC. Given DC is equal to 1/4 times of BC. So which means D is a point on the side BC. Then only we can take the condition BC is equal to 1/4 into BC. So suppose here we have the point D on the side BC. Let us take the point D on the side BC of a triangle ABC. Now join these 2 points, join A and D. To take the condition BC is equal to 1/4 of BC, we must have a point D on the side BC. Okay, so this AD is the line, new line. So now to prove this result, AD square is equal to 13 times of CD square. So by using construction method, so now draw a perpendicular from point A to side BC. This is perpendicular. Call this point as E. So now what is the construction part here, dear students? Draw AE perpendicular to the side BC. Once we draw AE perpendicular to BC, so clearly note that this AE is also bisecting the side BC of an equilateral triangle ABC. Once this AE is right angle to BC, so and hence this point E bisect the side BC of this triangle, which means this BE is same as EC. So which is same as 1/2 times of BC. Correct? So if AE is right angle to BC, then BE is same as EC, and then BE equal to EC equal to 1/2 into BC. Okay. So now we want to show that AD square is equal to 13 times of CD square. Now in this figure, consider the triangle ADC. In this figure, consider the triangle ADC. Consider the triangle ADC. Now we all know that there is an acute angle theorem. So why we need to apply the acute angle theorem? Because here in this triangle ADC we have the angle C is 60 degree. Why is that the angle is 60 degree? C is 60 degree because ABC is an equilateral triangle. All the angles, internal angles are equal. So therefore each of having measure of 60 degree. Since in this triangle ADC, if this angle C is 60 degree, so we can apply the acute angle theorem for this triangle ADC. What it says? The acute angle theorem says that the acute angle theorem says that this side AD square is equal to the side AC square AC square plus DC square or CD square minus 2 times of DC or CD into EC. So this is not particularly acute angle theorem. In fact, we can apply this result to any triangle with an angle which is less than 90 degrees. So that is one standard result in our class 10 syllabus. So because of this theorem, we can write AD square is equal to AC square plus CD square minus 2 times of CD into EC. Now, LHS we have already AD square, right? So AD square is equal to, now the idea is to prove that, now convert all these terms AC, CD and CD, this EC in terms of BC. We can convert these sides AC, AD, CD and BEC as in terms of BC. So now AC is one side of this equilateral triangle ABC, and we know that in this triangle all these sides are equal. So therefore AC is same as BC. So therefore AC square is nothing but BC square plus, now it is CD square. We know that by the given condition DC or CD both are same. DC square is equal to 1 by 4 into BC whole square. So CD can be replaced by 1/4 into BC the whole square minus 2 times of, again this CD or DC can be written as 1 by 4 into BC into this EC. EC is nothing but 1 by 2 times of BC. 1 by 2 times of BC. So now clearly all the right hand side terms are in terms of BC only, because we have BC and DC are in relation. Now AD square is equal to BC square plus, what is 1 by 4 into BC the square, which is 1 by 4 whole square. What is 1 by 4 whole square? 1 by 16 into BC the square minus, now these two gets cancelled, remains with 1 by 4 into BC into BC. What is BC into BC? BC square. 1 by 4 into BC square. Now look at the terms in the right hand side of this equation. BC square plus 1 by 16 into BC square minus 1 by 4 into BC square. So all the terms are same. Now take the LCM for these three. Now what is the LCM for? 1 and 1 by 16 and 1 by 4. So yes, correct. So which is 16. Now 16 is the LCM. Now take LCM as 16. Now here it is, we have 1 into 16 which is 16. This term will become 16 times of BC square plus, so 16 ones are 16. So 1 into 1 times of BC square minus, so here in the denominator we have 4 times of 16. So that 4 into 1 4 times of BC square. So now which is equal to 16 BC square plus 1 BC square, which is 17 times of BC square minus 4. 17 minus 4, which is 13 times of BC square by 16. So now finally we have AD square is equal to 13 by 16 into BC square. Now this can be rewritten as AD square is equal to 13, keep it as it is. 13, keep it as it is. Now BC square by 16. This 16 can be written as 4 square and this BC can be written as BC the square. So which is in total, by combining these two, 1 by 4 times of BC whole square. Correct? Now this BC square by 16 can be written as 1/4 times of BC whole square. Now by the given condition, we know that DC is equal to 1/4 of BC. So here we have 1/4 of BC. 1 by 4 into BC is replaced by DC. Clearly. So 13 times of 1 by 4 into BC can be written as DC whole square. So now at last we have AD square is equal to 13 times of DC the square. And hence the result. Thank you.